do on these is you're going to list the domain and the range. And you're going to set up a little set. Does anybody know how to do that bracket? Looks like a little face. And for the domain is the x's. You're just going to list the x's. And I like to list them in order. So you have a 3 and a 4 and a 6 and a 7. And you don't have to list 6 twice because it's already in the set. So there's your domain. 3, 4, 6, 7. Is that hard?
Yes. Yeah.
Terrible. Then you're going to do the range, and the range would be -2 is the smallest number I see. Then I see a 1. Then I see a 4, 8, and 9. And you're done with the first part of your question. Okay? Now we have to decide if this is a function or not. So what you're going to look for is repeats either in the x or in the y. And I see that everybody's cool except for these two 6's are the same with a different y. Does everybody see that? So you look for repeats. And off to the side, we're going to have a rule in a minute, but off to the side, if you do 6, -2, it's right here, and 6, 4 is right here. If they're in a vertical line, then it's not a function. So that means that if the x's repeat to different y's, it's not a function. So down here we're going to list the domain. And the domain is going to be -2, -1, 0, 3, and 7. Everybody see that? And the range is going to be, what's the smallest? -4, 1, 2, and 4. So now we're going to evaluate if this is a function or not, and I see that these two repeat themselves. So when I graph 0, 4, it's right here, and -2, no, 0, 4 is not there. 0, 4 is right here, and -2, 4 is right up here somewhere, right? It does not fail the vertical line test because they're in a horizontal line. So this is yes, a function. Okay? So if nothing repeats, it's a function. If the x's repeat and go to different y's, it's not a function. And if the y's repeat, it is a function. It's not a problem. Okay? So now we're going to evaluate if we have this like this. We have a set of numbers. It's a 2 and an 8. And another set of numbers is 21, 25, and 30. And the 2 goes to the 21 and the 25. And the 8 goes to the 30. And we're going to decide, we're going to state the domain and the range. Okay? What do you think the domain is?
2 and 8.
2 and 8 is correct. And what do you think the range is?
21, 25, and 30.
Perfect. Now we're going to decide if this is a function or not. Do you see anybody who repeats? Which one?
No.
I do. If I write these as points, I have a 2 and 21 and a 2 and 25. Does everybody see that?
Repeats.
So the 2 repeats. So is this going to be a function? Let's look. If I plot 2 over and 21, it's going to be way up here. And if I plot 25, it's going to be right above it, right?
Mm-hmm.
So this would fail the vertical line test. So it's not a function.
So pretty much any time they repeat it.
We're going to graph each of these. What does the line y equals 7 look like? What kind of line is that? Anybody know?
It's straight on the.
It's a horizontal line at 7. Let's look at that. Okay, I'm the town idiot. And no matter what you say, I just say 7. When x is 0, what is y?
7.
When x is -1.
7.
When,
7.
when x is negative 2.
7.
Got it? So if I plot those points, 0, 7 is here, negative 1, 7 is here, negative 2, 7, that's going to be a horizontal line.
So you can be an idiot.
Uh-huh. No matter what happens, y is 7. Because the equation is y is 7. That is a fact. Y is 7. No matter what. Got it? So if you ever forget, first of all, your calculator has a y equals screen. So if when you graph a y equals a number, it's a horizontal, you know that the x equals a number is going to be what? What's the opposite of horizontal?
Vertical.
Vertical. So we know that. So in this case, x equals 3, same thing. No matter what y is, x is 3, right? So that's going to be on this line. So now we have to decide which one of these is a function and which one is not. Any ideas on who is a function?
Conjunction.
Which one is the function of those two? Does this one violate the vertical line test?
No.
No, so this one's a function. Does this have more than one point on a vertical line?
Yes.
Yes, it has an infinite amount of points on that vertical line. So that is not a function. Well, what happened? You repeated the x's with different y's. You see it? This last part is about plugging into functions. If f of x is 5 over x plus 2, how would we find f of negative 3? What would we do? What do we do with that negative 3?
You plug it into the x.
You plug it in for the x, so it would be 5 over negative 3 plus 2, which is 5 over negative 1, which is negative 5.
Is that x plus 2?
Yes, it is. And now if they ask me g of 1, what will we do with that? Somebody else. What would we do to find g of 1? Plug it in where? The g of x. That's right. If they want g of 1, I go to the g of x function, and I have negative 2. We're going to plug in a 1 for x. And I have negative 2 plus 3, which is 1. So that's the answer to g of 1. Okay? Now it gets a little bit different. They want f of d, right? So what do I do with the d? What did I do with the negative 3? Plugged it in for
The x.
x. What do I do with the d?
Plug it in for the x.
You just plug it in for x. So f of d equals 5 over d plus 2. You don't simplify it. You just leave it alone. You're plugging in a d. You're not going to be able to do anything. Just leave it alone. And how do I find g of c minus 1? What do I do with this c minus 1?
You plug it in for the x.
And what I do is I take this negative 2, and I see the x there. I'm going to put a parenthesis in its place. I take the x out, and I put in the c minus 1. In this case, you can clean it up a little bit. Negative 2c plus 2 plus 3, which is negative 2c plus 5. So if you can clean it up algebraically, you do. If not, you leave it alone.